Ohm's law is one of the most important and foundational ideas in electricity, and understanding it allows us to predict and control how electrical circuits behave. At its core, Ohm's law describes the relationship between three key quantities: voltage, current, and resistance. Voltage, measured in volts, is the electrical pressure that pushes charges through a conductor. Current, measured in amperes, is the rate at which electric charge flows. Resistance, measured in ohms, is the opposition that a material offers to the flow of current. Ohm's law states that the current through a conductor is directly proportional to the voltage across it and inversely proportional to the resistance. Mathematically, the relationship is written as V equals IR, where V is voltage, I is current, and R is resistance. This equation tells us that if we increase the voltage while keeping resistance the same, the current will increase. If we increase the resistance while keeping voltage the same, the current will decrease. This simple equation allows engineers and students to analyze the behavior of almost any electrical device, from a small LED to a large household appliance. To understand it more deeply, consider a water analogy. Imagine voltage as the pressure pushing water through a pipe, current as the flow rate of the water, and resistance as the narrowness or friction inside the pipe. Higher pressure leads to more flow, while tighter pipes reduce the flow. Ohm's law gives us a quantitative understanding of this relationship inside electric circuits. For example, if a resistor of 10 ohms is connected across a 5-volt supply, the current can be calculated as I equals V divided by R, which gives 0.5 amperes. This shows how mathematics allows us to predict what happens inside the circuit. Another important concept connected to Ohm's law is electric power. Electric power tells us how fast electrical energy is being converted into other forms such as heat, light, or motion. Power is measured in watts and is given by the formula P equals VI, meaning power equals voltage multiplied by current. When we combine Ohm's law with this power formula, we can express power in two additional ways: P equals I squared R and P equals V squared divided by R. These forms are extremely useful. For example, the equation P equals I squared R explains why wires heat up when large currents pass through them. The heating effect depends on the square of the current and the resistance of the wire. Similarly, P equals V squared divided by R is helpful when the voltage is known, but the current is not. Together, Ohm's law and the power equations make it possible to design safe circuits, choose the correct resistor values, prevent overheating, and ensure devices operate correctly. Almost every calculation in electronics begins with these formulas. By mastering them, you gain a deeper understanding of how energy flows, how electrical components behave, and how to control them using simple mathematical relationships.